Hello students, in my last video I just completed depression freezing point concept and I also started osmotic pressure. In that osmotic pressure we have completed Van Hoff's law of dilute solutions. According to Van Hoff law, then this formula already we have derived then. Means according to Van Hoff, how gases behaves ideal gas equation, dilute solutions also behaves gas equation, ideal gas equation, just by replacing a P, pressure P with the pi symbol, that's it. Pi V equal to nRT and pi V equal to N, nothing but a number of moles of solute, mass by molar mass of solute by molar mass of solute into RT. And I want M2 molar mass of solute will just interchange, will shift here, pi V is going here, therefore W2 RT by pi V. W2 mass of solute, R gas constant, T absolute temperature, pi osmotic pressure, volume V in liters, right. Then based on this formula, we will solve some questions. In that one of the question is like this. That is 200 centimeter cube of an aqueous solution. Volume has given in milliliters. Centimeter cube is nothing but a milliliters. That is a volume 200 centimeter cube of an aqueous solution of protein contains 1.2 grams of protein. 1.2 grams of protein is nothing but a W2 mass of protein, nothing but a solute has given in the question. The osmotic pressure of such a solution at 300 kelvins, temperature also given, is found to be pi value also given, and is asking calculate molar mass of protein. We will just copy this formula here as it is. But before that, I will write it's a given data. What data he has given? Volume 200 centimeter cube. But volume we must convert into liters. Divided by 1000. 200 divided by 1000. Two zeros cancel. 2 by 10 is nothing but a 0.2 liters is the volume. Yeah, next what he has given, W2 has given. W2 is 1.26 grams. Next what he has given, temperature is 300 kelvins. And next osmotic pressure, pi is equals to 2.57. 2.57 into 10 is to minus 3 atmosphere. And next is asking a M2 molar mass of solute. And one more very important thing is R value. R value is a gas constant. Now we are using here as a solution constant. Now which one we have to take? Which R value we have to take? That we have to decide based on given volume as well as given pressure. Given volume units as well as given pressure units, we have to select R value. Now volume I have taken in the liters. And the pressure we are using in atmosphere. It is a liter, it is atmosphere. Pressure in the atmosphere, volume is in liters. Means R value should be liter atmosphere related value. That is 0.0821 liter atmosphere per mole Kelvin. That's it. Now I'll just copy the formula. That is a M2 molar mass of solute is equals to, that is a W2 RT divided by pi V. W2 RT divided by pi V. W2 value will just substitute 1.26 into 0.0821 into temperature 300 kelvins divided by pi osmotic pressure 2.57 into 10 to the power of minus 3 and into volume 0.2. If you just simplify those values, then you will get a 61,022. That is molar mass of solute 61,022 gram per mole is obtained. Right, because we have taken a protein. Protein is a polymeric substance. Molar mass will be higher. We are getting a 61,022 gram per mole is obtained. That's it. This is one question and it's a solution related to molar mass related formula. Next, same formula, I mean similar formula. One more question, just we'll see then. Okay. Yeah, next question is quite similar to previous question only. That is 100 milliliters of solution. 100 milliliters of solution is nothing but volume has given again in the milliliters. We have to convert into liters. Solution contains 3 grams of solute X. That is nothing but a W2. Mass of solute has given. Shows osmotic pressure of 2.051 atmospheres. Pi value has given in the atmospheres. Listen here. Volume we are converting into liters. Volume will convert into liters, and pressure has given in the atmosphere. That's why R value again we have to take a liter atmosphere related value only. Again is asking molar mass of solute. M2 he is asking quite same formula and same type calculation. If you do, you will get a molar mass, that is 360.26 gram per mole is your answer. This is your homework. It's quite similar only. There is no any difficulty in this question. Okay, right? I will say next question then. Okay. Okay, next question is like this. Calculate osmotic pressure. He is asking here osmotic pressure pi value, that is in Pascal. Osmotic pressure in Pascal exerted by a solution prepared by dissolving 1 gram of polymer, that is a solute. W2, and its molar mass also given, molar mass M2 also given, remember 1,85,000, that is molar mass, because it is a polymer, its molar mass is very higher. Then in 450 milliliters of water, volume has given in milliliters. Again we have to convert milliliters in liters. Next, temperature given 37 degrees centigrade. What we have to calculate? Osmotic pressure we have to calculate. Let's see then how to calculate osmotic pressure. Right, pi is question mark, that too we have to calculate in Pascal only. Right, next W2 value 1 gram, M2 value something given, molar mass 1,85,000 gram per mole. Next, volume 450 divided by 1000 liters, because we want to take in liters. Temperature 37 plus 273. Then if you add you will get 310 kelvins. Yeah, then one more value is needed, R. Solution constant, nothing but gas constant here. How much we have to take is question mark. Anyhow, volume is in liters. Volume is in liters and pressure is in Pascal. Pressure is not atmosphere, remember, it is in Pascal. Pascal liter, related R value we have to select. That's why its value is, its R value is 8.314. 8.314 into 10 cube Pascal liter per mole Kelvin. This is R value, remember. And pi value asking. Then we'll have the regular formula. Pi V equal to nRT. And pi, we'll calculate pi equal to nRT divided by V is our formula. Okay. Now we'll just substitute the values. Then pi equals to n nothing but number of moles of solute. Number of moles of solute means mass of solute by molar mass of solute. That's why instead of n, or we can say n2 doesn't matter. Therefore, W2 divided by M2 RT divided by V. Then a W2 value, molar mass of solute is just 1 divided by molar mass of solute is 1,85,000 and into R value is 8.314 into 10 cube. 8.314 into 10 cube. Into temperature is 31 kelvins divided by volume. If you divide this one 450 divided by 1000, you will get 0.45. 0.45 directly you can write in liters. If you simplify the entire value, then you will get nearly 31 Pascal. pi value you will get 31 Pascal is obtained. Actually 30.9 something you will get, and it's a round figure value will take as 31 Pascal is our answer. This is the question. Okay, see here osmotic pressure asking, and 1 gram solute mass given and its molar mass given, volume given in the milliliters, and temperature given in the degree centigrade, and this milliliter converted into liter, degree centigrade converted into Kelvin. Why? Because R value is related to Kelvin and liter and Pascal. That's why all values, pressure will get in Pascal, volume should be in liters, temperature should be in Kelvins, then only you will get answer. Temperature degree centigrade, R value Kelvin, you will not get proper answer. Volume milliliters, R value is a liter related value, again you will not get answer. Similar units we have to maintain. Okay, right. Next we will discuss about types of solutions. Types of solutions based on osmotic pressure. Yeah, based on osmotic pressure, we'll have different types of solutions are there. In that, first I'll explain about isotonic solutions. Isotonic solutions. Then what are isotonic solutions? Very simple. If solutions are having same osmotic pressure, if two solutions are having same osmotic pressure, then they are called as isotonic solutions. Say for example, it is a solution sample 1 and it is a solution sample 2. It is 1, it is 2. If both are having same pi 1, it is pi 2. If both are having the same osmotic pressure, then they are called as isotonic solutions. Therefore, we will write like this: isotonic solutions means contain the same osmotic pressure. We will take its formula, because pi equal to CRT in last video I explained. I will write like this: C for first solution concentration, and here pi 2 C2RT at same temperature of course, and both RT cancel, therefore C1 equal to C2. Remember for isotonic solutions, osmotic pressure same, simultaneously their concentration is also same only. Isotonic solution means osmotic pressure will be same, simultaneously their concentration also is same. Right, just will extend the formula. It is a concentration, nothing but a molarity. We will take first sample molarity formula, W1 by M1 into 1000 divided by V1. V1 I am taking. See, W1 means don't think that it is a mass of solvent. 1 means not solvent. 1 means sample 1 related formula. Now is equals to. Now sample 2 related formula I will write. Okay, sample 2 related formula, W2 by M2 into 1000 divided by V2. Why? Isotonic solutions are having the same concentration values. That's why both concentration formulas I am just equalizing. We are equalizing. It is a sample 1 concentration, sample 2 concentration. Okay, it is a W1 means a mass of solute only, solute of sample 1. Molar mass of solute of sample 1, volume, of course, it is a sample 2 solute, sample 2 molar mass. Okay, right. Then 1000 cancel if you do. What we will get then? W1 by M1 V1 is equals to W2 by M2 V2 we are getting. Then already known to you, W1 by M1, mass by molar mass is nothing but a number of moles. That's why instead of this term I can write N1 N2. Therefore you will get N1 by V1 is equals to N2 by V2. It is another formula we can derive like that. Okay, why? Because both osmotic pressures are same. Okay, right. Then best example for isotonic solution is 0.9%. 0.9% mass by volume. NaCl is isotonic with blood. This is important point. Blood is isotonic with human blood is isotonic with 0.9% W by V of NaCl. Okay, both are having the same osmotic pressure, 0.9% W by V NaCl and the blood. They are isotonic solutions. Isotonic solutions, and this 0.9% W by V NaCl is also called as saline. Saline bottle, saline is isotonic with the blood, of course, having the same osmotic pressure as well as the same concentration. Right, now based on isotonic solutions, we'll solve one question, one problem we'll see then, okay? Yeah, next, question based on isotonic solutions, let's see now. Here a 5% W by V solution of cane sugar. Cane sugar is isotonic with 0.877% W by V solution of unknown solute. One is cane sugar, one is unknown solute. What is unknown solute? We don't know. And both percentage by volumes has given, and is asking find the molar mass of unknown solute. Unknown solute molar mass is asking. Then how to solve this question? First we will understand 5% W by V solution of cane sugar. What is the meaning? Means 5 grams, W is nothing but grams. 5 grams of cane sugar. 5 grams of cane sugar is present in 100 milliliters of solution. Its meaning is 5 grams of cane sugar is present in 100 milliliters of solution. Come here. 0.877% W by V means 0.877 grams of unknown solute is present in 100 milliliters of solution. Of course, both the components volume is same. That's why what I am doing. One is the cane sugar and another one is unknown solute. Unknown solute, right? And here they are isotonic. Important point is they are isotonic, means both osmotic pressures are same. Both osmotic pressures are same. Therefore, osmotic pressure of cane sugar is equals to osmotic pressure of unknown solute. This he has given in the question only, right? Then osmotic pressures are same is automatically concentrations also. Cane sugar concentration, unknown solute concentration, both concentrations also same only. That's what I am doing now. Here I will write the formula, that is first for cane sugar we will write the formula, otherwise here only we will write. Cane sugar like W1. Cane sugar I am taking sample 1, it is a sample 2. W1 by M1 into 1000 divided by V in milliliters is equals to, it is a sample 2, W2 by M2 into 1000 divided by volume in milliliters. Because both osmotic pressures are same. If osmotic pressures are same, automatically concentrations are same. It is a sample 1. Cane sugar I am taking it as sample 1. It's a related formula. Unknown solute is sample 2. It's a related formula I have taken. Your thing is, then we can cancel similar terms. What we can cancel? 1000. And here this volume same. V cancel. That's it. Then we will get only W1 by M1 is equals to W2 by M2. W1 by M1 is cane sugar values. W2 by M2 is unknown solute values. That's why I want M2 unknown solute molar mass is needed. Unknown solute molar mass purpose, what I am doing now, M2 will bring LHS. M2 is equals to cross multiplication. M1 W2 divided by W1. Okay? Therefore, M1 value how much? M1 is nothing but molar mass of cane sugar. Molar mass of cane sugar, that is 342. C12 H22 11. 342 into W2. That is a second sample molar mass. 2 is nothing but second sample. 1 is nothing but first sample. Second sample mass 0.877 divided by W1. First sample mass. Who is first sample? Cane sugar. 5 grams. 5 grams. If you do the simplification, If you do the simplification, you will get a molar mass is 60. That's it. 60 gram per mole is obtained. This is your answer. M2 equal to this. Means this unknown solute molar mass we are getting 60. That's it. How we are getting? Because both are isotonic as mentioned. Both osmotic pressures are same. Simultaneously concentrations are same. It is a cane sugar. No confusion. It is unknown solute. Cane sugar I am taking it as sample 1. Unknown solute I am taking it as sample 2. That's why cane sugar related values indicated with M1. I mean, one symbol we have indicated. And unknown solute we are indicating with the 2 symbol. And 1000 we can cancel. V also we can cancel because both are having the same volume. Therefore, W1 by M1, then these two are cane sugar values. These two are known solute values. By substituting values, you will get a molar mass of solute of, molar mass of unknown solute is obtained. Next, we'll discuss about hypertonic solution and hypotonic solutions. We'll see that. Now we are discussing this phenomena based on osmotic pressure only. Already we have learned isotonic solutions. Isotonic solutions means the solutions whose osmotic pressure are same called as isotonic solutions. Now we will discuss what are hypertonic solution and what are hypotonic solutions. Hypertonic and hypotonic solution. Hypertonic and hypotonic solutions. Let's discuss now. Very simple. It is a sample 1. Sample 1. It is a sample 2. Right. Now, which is hypertonic solution, which is hypotonic solutions, how to define? Very simple. Then out of these two, whose osmotic pressure is higher? Whose osmotic pressure is higher than other sample? That is hypertonic solution. Suppose sample 1 osmotic pressure is bigger than sample 2. Sample 2 osmotic pressure related as pi 2. If sample 1 osmotic pressure is bigger than sample 2 osmotic pressure, then this solution is called as hypertonic solution. Remember, hyper is nothing but more. Hyper is nothing but more. That's why then the sample 1 is called a hypertonic solution. Obviously, sample 2 is called as a hypotonic solution. Means whose osmotic pressure is less than other solution is called a hypotonic solution. It is a hypertonic solution. That's it. Means pi 1 greater than pi 2. Means out of these two solutions, sample 1 osmotic pressure is more. Sample 1 is called as a hypertonic and sample 2 osmotic pressure is less. That's why it is called as a hypotonic solution. That's it. Now I'll give you one simple example regarding this hyper and hypotonic solutions. What we'll do now, see here. Here I'll take one sample. Here also same. I'll take one solution, of course. Solution sample I have taken. Right. First we'll discuss about case 1. Next we'll go to case 2. Right. Now what I am doing, one animal or plant cell. Animal cell or plant cell will keep in the first sample. I'll repeat. When animal cell or plant cell is kept in the sample 1. Now here when you are comparing animal cell or plant cell concentration and outer solution concentration, when you are observing to each other, then outer solution concentration is more. Outer solution concentration is more and our plant cell concentration is less. Plant cell concentration, less concentration plant cell, more concentration is outer solution, right? Means concentrations difference means automatically their osmotic pressure is also different. Once again, it is a plant cell or animal cell, anyone has kept in hypertonic solution. Remember, Hypertonic solution means comparing with its inner liquid. Comparing with its inner liquid, outer solution osmotic pressure is more. That's why then plant cell has kept in hypertonic solution according to osmosis phenomena. What is osmosis? Osmosis means flowing of liquid from lower concentration region to higher concentration region. Here also inside is lower concentration region, outside is higher concentration region. That's why whatever the liquid is there, that liquid, whatever the liquid is present in the plant cell or animal cell will come out from the liquid. Okay, will come out from the liquid. Because of that reason, what happened? That plant cell or animal cell becomes shrinking takes place. Why shrinking takes place? The entire liquid is coming out. Why? Because inside is lower concentration, outside is a higher concentration. Means always according to osmosis phenomenon, liquid will come out from lower to higher concentration region. Because of that reason, our plant cell or animal cell becomes shrinking. This phenomena particularly called as plasmolysis. Particularly, plasmolysis is also part of osmosis only. Plasmolysis also part of osmosis phenomena only. In plasmolysis, what happens? Whatever the cell we are using, the cell becomes shrinking. Come on, case 2. Case 2, what I am doing? It is again animal or plant cell. Animal or plant cell, and now this cell has kept a solution whose concentration is less than plant cell concentration. I'll repeat. When we are comparing both the concentrations, here outer solution is hypotonic. Here outer solution is hypertonic. Here outer solution is hypotonic. But inside the plant concentration is more. Inside the plant, whatever the liquid is there, that is hypertonic. Remember, both are opposite phenomena. Here outside solution is more concentration, inside solution is less concentration. Here inside solution is more concentration, outside solution is less concentration. Automatically, according to our osmosis phenomena, what happens? The entire liquid, the outer liquid will enter into plant cell or animal cell. Because according to osmosis phenomena, the liquid will travel from lower concentration region to higher concentration region. That's why from higher to lower liquid is going. Because of that reason, that a plant cell bulges. Here a plant cell becomes shrinking, but here it is a bulging, it is a bulges. This particular phenomena is called as hemolysis. Shrinking is called plasmolysis. Bulging is called hemolysis. Shrinking is called plasmolysis. Bulging is called hemolysis. Of course, both hemolysis as well as plasmolysis, both are part of osmosis phenomena only. Right. Now, based on this hypertonic as well as hypotonic solutions, we'll see some more examples in our day-to-day life activities. Okay? Yeah, we'll see some day-to-day life examples regarding osmosis process. We'll see now a raw mango. Of course, first application just now we have discussed then in plasmolysis process. A raw mango placed in concentrated salt solution loses water via osmosis and shrinking and make into pickle. In pickle manufacturing, the same phenomena takes place. There is a raw mango, after preserving in salt solution, it becomes shrinking, and that only will use as a mango pickle, because mango piece becomes shrinking, shrivel, nothing but shrinking. Right. Second one, wilted flowers. Wilted flowers again revive when placed in fresh water. On flowers, if you sprinkle some water, again those flowers will shine again because of osmosis process only, because water molecules will enter into flowers via osmosis phenomena. Right. And a carrot, same formula again. A carrot that has become limp. Nothing but a shrinking carrot. Limp after placing in water. On this limped carrot, we have to sprinkle again some water. Definitely water is going into carrot. After placing in water, can make it firm again. Again it becomes a bulging. Carrot seems to be fresh because water has entered in it due to osmosis process. Will feel it is a fresh carrot, of course. Then next, here people generally taking a lot of salt as well as salty food experience water retention in their tissues in their cells due to osmosis, of course, resulting puffiness, that is nothing but swelling, is called edema. Means the peoples who are taking more salty food as well as more salt, what happens in their body cells, concentration is more. That's why when we are drinking water, what happened then? Water travel from low concentration to high concentration region. That's why whatever we are consuming water, that water is going and depositing in the tissue cells. Okay, because tissue cells are more concentrated. That's why water is going and retention takes place. Because of that, people will feel puffiness. Swelling takes place, bulges. Puffiness will feel. That disease is called as edema disease. And next, water movement from soil into plant, water moving from soil into plant root and subsequently and upper part of that plant is due to osmosis only. Water will start moving from root to entire plant is because of osmosis phenomena only. And next, last point is the preservation of meat by salting out. On meat, we have to sprinkle some salt as well as fruits. On fruits, we have to sprinkle some sugar. I'll repeat. Then how we are preserving meat? By adding some salt. How we are preserving fruits? By adding some sugar. Then what happened? They'll preserve for some days. Why? What happened means, see here what happens? By adding sugar, protects against bacterial action through osmosis process. What happens means, when we are adding some salt in meat, some sugar in fruits, when bacteria attacks on those substances, then here these are more concentrated. Our bacteria inside liquid is less concentrated. When bacteria attacks, say it is bacteria. When bacteria attacks on these substances, what happened? They are more concentrated. These are more concentrated. And our bacterial liquid is less concentrated. Definitely bacteria losing water. Bacteria loses water. Bacteria ultimately will shrink and finally it dies. That's why we'll preserve like this. These are our day-to-day life applications regarding osmosis process. Okay, right. Then we'll enter into last topic of this lesson, that is a reverse osmosis process. Reverse osmosis. Let's see now. Yeah, reverse osmosis. RO. Yeah. Further purpose, once again, we'll draw a diagram, same diagram already, where we have drawn at the time of osmosis process. See here. We'll keep here one semi-permeable membrane. Left side we have taken a pure solvent. Right side we have taken a solution. It is a solvent. It is a solution. It is a semi-permeable membrane. On the solution side, we will arrange one piston. And we are applying some pressure with the help of piston. Then what is osmotic pressure? Already known to you. Okay, what is osmotic pressure? Means the external pressure. The external pressure where or at which the osmosis process has stopped, that is called as osmotic pressure, that already we have defined. Now we are discussing reverse osmosis. Now in reverse osmosis, what we have to do then means, here suppose To stop the osmosis process, we are applying. To stop the osmosis, I am telling. To stop the osmosis process, I am just applying the pressure. I applied like 1 atmosphere, 2 atmosphere, 3, 4, 5. Suppose at 5 atmospheres pressure, suppose I am telling at 5 atmospheres pressure, osmosis process has stopped, of course. Then we can say that it is osmotic pressure. Now what is reverse osmosis? Now what I am doing? Then with the help of this piston, more than 5 atmospheres pressure I am applying. I will repeat, 5 atmospheres is the osmotic pressure. Now what I am doing on the solution side only, more than osmotic pressure. More pressure, more than osmotic pressure, that is like it may be 6 atmospheres, 7, 10, etc. Then I am applying 7 atmospheres pressure on the solution side, which is more than osmotic pressure. Now what happens? Now what happens means here a reverse phenomena takes place. A reverse phenomena means from that is it is a solution. Solution is having a solute and a solvent. Now we are applying the pressure which is more than osmotic pressure. In this case what happened? Whatever the solvent is present at the solution side, whatever the solvent is present in the solution, that solvent will move through the semi-permeable membrane into pure solvent. From solution, solvent is traveling into pure solvent through semi-permeable membrane. This phenomena only called as reverse osmosis process. In osmosis process what happened? Solvent to solution. Solvent to solution liquid travels. That is normal osmosis process. Now we are doing here reverse osmosis. Reverse osmosis means we are applying pressure which is more than osmotic pressure. In this case what happened? The solvent molecules from solution will travel, will enter through semi-permeable membrane into pure solvent in a reverse direction. That is a liquid is moving. This phenomena only called as a reverse osmosis process. That's why how to define a reverse osmosis process means the external pressure which we are applying is more than osmotic pressure. The external pressure which is more than osmotic pressure, in that case the solvent moves from solution to pure solvent. Solvent moves from, this solvent is moving from solution to pure solvent via semi-permeable membrane is called as reverse osmosis process. Generally, this reverse osmosis process will be used for the desalination of seawater. Desalination of seawater to get drinking water, pure water. Means seawater purification purpose will use this desalination method. Remember, means what we are doing? We are applying external pressure which is more than normal atmosphere, which is more than osmotic pressure. In that case, solvent from solution is moving into pure solvent through semi-permeable membrane is called as reverse osmosis. This will use for the desalination of seawater to get drinking water. In this process, remember, cellulose acetate is used as a semi-permeable membrane. That's it. In this phenomena, this semi-permeable membrane will use as cellulose acetate. Okay, right. From this we have completed successfully solutions topic. Actually, after reverse osmosis, we are having one more topic, that is abnormal molar mass. But this year our PU board has deleted that topic. Abnormal molar mass has deleted this year because of this pandemic situation. That's why abnormal molar mass concept I am not explaining. I am just stopping up to reverse osmosis only. Okay? Then abnormal molar mass, that concept we'll see in our regular class at the time of competitive examination. Okay, right. Before we're going to conclude, before we're going to stop, then one important thing is already at the time of vapor pressure, lowering of vapor pressure, relative lowering of vapor pressure, we have learned their formulas, particularly lowering of vapor pressure, lowering of vapor pressure, that is a delta P we have taken formula, lowering of vapor pressure formula, please try to remember, it is P1 naught minus P1 we have to take. At the time of in the videos, I think this one symbol I may missed, but please try to remember it is a P1 naught minus P1 or P1 naught minus P solution also we can take. Then one solution, what is the link, everything I explained in our previous videos. Okay, here this one I think I have missed, that you just make it the correction. And a relative lowering of vapor pressure also, formula is the same, P1 naught minus P1, because these symbols are given in our NCERT book only. According to NCERT book only, I am giving the symbols. Okay, divided by P1 naught. This is a relative lowering of vapor pressure formula. Wherever if I miss suppose this one symbol, you just make a correction, that's it. Okay, from this we have completed our solution topic successfully. If you are having any doubts in this lesson, please feel free to contact me, and a number you can take from a college office. Okay, thank you for watching. Bye.